So far, we have only simplified radicals when the contents of the radical was just a number. So for example, to simplify the square root of 80, we notice that 80 is a multiple of 16, which is a perfect square. So the square root of 80 is the square root of 16 times 5, which works out to 80. That's the square root of 16 times the square root of 5. And actually taking the square root of 16, that's 4 times the square root of 5. And we can do this simplifying. The reason that this simplifies is that we can actually take the square root of 16. We know what the square root of 16 is. It's just the number 4. When we're working with variables and we have something that we can take the square root of, there's a complication that comes up. Let's think about what happens if we have just the square root of x squared. So notice the squared is inside the square root. If we plug in x is 3, then we have the square root of 3 squared. But 3 squared is just 9. So this gives us 3. On the other hand, the square root of negative 3 squared, negative 3 squared is also 9. So that also gives us 3. If we take the square root of 5 squared, well, 5 squared is 25. So this gives us 5 back. But negative 5 squared is also 25. So that also gives us 5 back. When our x value is a positive number, squaring it and then taking the square root gives us our number back. But when we have a negative number, we square it and we get a positive number. And then when we take the square root, we get the positive square root. If we take the square root of x squared, we don't get x back. We get the absolute value of x. Whatever x was, we make it positive now. Let's see if that happens for other exponents. Let's see what happens, for example, if we take the third root of x to the third. If we take 3 to the third, that's 27. So here we have the third root of 27, which is just 3 again. If we take negative 3 to the third, though, that works out to negative 27. And we can take the third root of that. That just comes back to negative 3. If we take 5 to the third, that's 125. And then we take the third root of that, we get our 5 back. If we take negative 5 to the third, that's negative 125. Taking the third root of that, we get our negative 5 back. But the third power didn't do what the second power did. When we take the third root of x to the third, we get x back. And of course, the difference here is the difference between an even power of x, so an even number of negative numbers multiplied together giving us something positive, versus an odd power of x, an odd number of negative numbers multiplied together giving us something negative again. For the same reason that the even power functions are not one-to-one, while the odd power functions are, when we take the square root of x squared, or an even root of x to an even power, we have to take the absolute value. When we take an odd root of x to an odd power, we just get the original number back. And here's a summary of that. Right? If we have an even power, then the pth root of x to the p is the absolute value. If we have an odd power, then the pth root of x to the p just gives us x back. So for example, 2 is even. So if we take x squared and take the square root, that's the absolute value of x. 3 is odd. So if we take x to the third and then take the cube root, we just get x back without the absolute value. 4 is even. So if we take x to the fourth and then take the fourth root, that gives us the absolute value. 5 is odd. If we take the fifth power and then the fifth root, we just get our x back. And this is something that we need to keep in mind when we're simplifying radicals. Other than this, everything works the way that we think it does. Right? We can take the pth root of the pth power. It's just that if p is an even number, we have to take the absolute value. We have to make the result positive.